In this session, I will discuss about controllability and observability, and the book I have referred here is by Nagur Kani. So first we will see what is controllability. Controllability, it actually specifies the usefulness of your state variable. So the definition is actually given by this statement that system is controllable means you can control the state of the system. That means if you have an initial state x of t0, you can transfer that state to any other desired state x of td by means of some control vector. That is, your system is controllable. So in order to check the controllability, there are two tests, Kalman's and Gilbert test. We will be discussing only Kalman's test here. So what is the Kalman's test for controllability? So before going to this topic, you should first go through what is state model, and you should know what is state equation x dot equal to x plus bu, and the output equation y equal to cx plus d. You should know how to form this state model. Okay, so this you should know in prior. Now in Kalman's method of testing controllability, what you will do is you first form the matrix QC by means of this state equation. You know, in state equation ax plus bu, you know what is a and what is b in the state equation. I hope you already know the state equation. That is, we are writing x1 dot, x2 dot, etc. up to xn dot in terms of a matrix A, x1, x2, etc. up to xn plus b into u. So this is the matrix A and this is the matrix B. So this is the state equation. So first form the state equation and form the matrix B, A into B, A square into B, etc. up to A raised to n minus 1 into B, where n is the number of the state variable. If I have three state variables x1, x2, x3, my matrix will become B, A, B, A square B, because n minus 1 equal to 2. So this is a matrix QC. Then how to check the controllability of the system means find out the determinant of this matrix QC you have formed, and the determinant is not 0 means your system is controllable. So this is how you check the controllability using Kalman test. Now observability. Observability means your state variable is observable or measurable. So the definition is given by this statement. System is observable means your state variable is completely measurable or identifiable by measuring the output y of t. That is the definition for observability. Again, you have the Gilbert test and Kalman's test. We will be discussing only Kalman's test here. Now, you see what is a Kalman's test of observability. So in Kalman's test of observability, what you are going to do is, again, first you should know the state equation and the output equation. So where you know what is A, B, C, D, and form the matrix QO. QO is given by C transpose, A transpose into C transpose, A transpose square into C transpose, etc. up to A transpose raised to n minus 1 into C transpose. So form this matrix. Then find out the determinant of this matrix QO. If the determinant is non-zero, your system is completely observable. That is the condition. So we will see one problem. So this is one question in which you have to check whether the system is controllable or observable. So the first step is you have to form the state model. That is both the state equation as well as output equation. So you know the state equation x dot equal to ax plus bu and output equation y equal to cx plus du. So first you form this state model. So if you are, sometimes you may be given the differential equation, or you can be given the signal flow graph or anything, whatever be given. First step is to write down the state model, that is write down the state equation and the output equation. So if here you have the block diagram. So in block diagram case, what you do is you take the first block, write down what is the input and the output to this block. So the output is x1. What is the input to this block is x2 minus x3. x2 minus x3 is the input. So write down the equation for your output. Output x1 equal to x2 minus x3 into 2 by s into s plus 1. This cross multiply this, open the bracket, you will get the equation. Now what I need is I want to write down the equation for x dot equal to x plus bu4. Okay, so I should get the derivative term here. So what you do is here I have x square into x1 of s and s into x1 of s. So this is not in s domain. So what I need to do is I take the inverse Laplace transform. So you take the inverse Laplace transform of your equation, what you obtain. Take the inverse Laplace transform. So you can see s square into x1 of x, that is the second derivative. S into x1 of x, inverse Laplace transform means the first derivative. S into x1 of x is first derivative. S square means second derivative. Then 2 into x2 of s, inverse is x2 as well. 2 into x3 of s, inverse is x3. So you'll get the first equation. Then take the second block. Again, write down what is the input, write down what is the output. Write down the equation. Take the inverse Laplace transform. You will get the next equation x3 equal to x1 dot. So from this you will get the first one, that is equation for x1 dot. Similarly, consider the third block. Again you write down what is the input as well as the output. Write down the equation. Simplify this. So you will get the equation like this. Okay, again take the inverse Laplace transform, write down the equation. From this you will get x2 dot. So we will get the second equation, that is equation for x2 dot. So I have considered all the block. I got is x1 dot and x2 dot. Now I need to know what is x3 dot. So what you obtained in the first equation was x1 double dot. Okay. So if I can replace this, what I need is x3 dot. Okay, if I can replace this in terms of x3, that will be useful. So just see, you already have the equation 1 in which you have x3 equal to x1 dot. So what will be x1 double dot? X1 double dot will be equal to x3 dot. So this I can substitute it as x3 dot. So what is x1 dot? X1 dot is actually x3. So substitute this, from this you will get the equation for x3 dot. So the next step, how to get x3 dot. Replace x1 double dot as x3, x1 dot as x3 cell. Then from this you will get x3 dot. So this is your third equation, that is equation for x3 dot. Now you have all the equation for all the state variable x1 dot, x2 dot, x3 dot. Write down the equation. Now write down the output equation. So from the figure you can see y, output y is x1 xl. Just refer your figure, you can see output y. This is your output y is x1 xl. So write down the equation for your output y. Now you have the state equation as well as the output equation. Write it in the matrix form. You know how to write it in the matrix form. I have the equation like this: x dot equal to a into x, x1 x2 x1 plus b into u. Similarly, y equal to c into x plus d into u. Okay. So write down this in the matrix form. This is x3. So the first x1 coefficient, x2 coefficient 0, x3 coefficient is 1 and u coefficient is 0. Then consider the second equation. X1 coefficient is minus 2, x2 coefficient is minus 3, x3 coefficient is not here. So it is 0. Then you have the coefficient as 2. So u coefficient is 2. Then write down the equation for the third one. X1 coefficient is 0, x2 coefficient is 2, x3 is minus 3 and u coefficient is not there, 0. So write down the state model. Similarly, write down the equation for y1. y1 you have only x1 coefficient. So x1 coefficient is 1, remaining all are 0 and d and u again. D coefficient is 0. So write down the equation first. Now you have all the terms a, b, c and d, where d is 0. So you have all the terms now. Now, to check the controllability and observability, we are going to use the Kalman test. So, according to your Kalman test, first to check the controllability. I am not discussing the Gilbert test now, going directly to the Kalman test. So, see, to check the controllability, I have to using the Kalman test. So, the equation is first form the matrix B, A into B, etc. up to A raised to n minus 1 into B. Here you know n equal to 3. I have x1, x2, x3, 3 state variables. So n minus 1 is 2. So I have the matrix B, A, B, A square B. So first form this matrix. Okay. B you already know, that is 0 to 0. Okay. Then A into B. You have A, you know, B, you know. So A into B, you will get this matrix. So that is 0, minus 6, 4. Then next is A square into B. What is A square? A into A. A into A is A square. You will get A square. Then A square into B is A square into, multiply it with B. You will get this matrix. This is A square into B. So write down A square into B. So just see, writing this you will get a 3 by 3 matrix QC. Now to check the controllability, what you need to do is find out the determinant of this matrix. So find out the determinant. You know how to find out the determinant, or you can use a calculator to find out the determinant. So you'll get the determinant here. So what you get is 32. It is not equal to 0. If it is not equal to 0 means your system is controllable. This is how you check the Kalman test for controllability. Now to check the Kalman test for observability, what you know is you construct this matrix QO. Okay, QO is C transpose, A transpose, C transpose, etc. up to A transpose rise to n minus 1. Here n minus 1 is 2 here. Okay, so rise to A transpose square into C transpose. So first is C transpose. You know, this was your C 1 0 0. That is y equal to C into U 1 0 0 into Cx. Sorry, C not Cu, Cx 1 0 0 into this plus 0, is it? So this was your C. So C transpose will be 1 0 0. So first one is C transpose 1 0 0. The second element is A transpose into C transpose. So first write down what is A transpose. So you know A. So A transpose, just write down is transpose. You will get A transpose. Then C transpose is given by this into C transpose. So when you multiply this, you will get a matrix like this. Okay. 0 0. So write down is the second element. Then the next element is A transpose square into C transpose. So you know what is A transpose? So A transpose square means A transpose into A transpose. Find out its value. You will get a 3 by 3 matrix. Then you want to find A transpose square into C transpose. Multiply it with C transpose. So this is A transpose square, then into C transpose. So you will again get a matrix like this. That is a 3 by 1 matrix. Write the column matrix here. So this is your QO now. So you have formed the matrix QO. So this is a matrix QO. Find out the determinant. So when you find out the determinant, you will get its minus 2. That is, it is again not equal to 0. That means your system is completely observable. So this is how you check whether the system is controllable or observable. So keep in mind, whenever you given some differential equation or signal flow graph or block diagram, etc., the first step is to form the state model, that is x dot equal to ax plus bu and y, output y equal to cx plus du. So form the state model, then form the controllable matrix QC or form the observable matrix QO from these values of A, B, C and D, and check whether the determinant of this is non-zero. So this is how you check for the controllability and observability of the system. Okay, thank you.